Advanced Math Lesson 31, Symmetry, Reflections, and Translations. All three of these words refer to our functions. The first one, symmetry, easy enough, is talking about when a function shows up on a graph. Here we have two examples of symmetry in functions. This first example, y equals x squared, is a graph that is symmetric about the y-axis, meaning that it gives the exact same picture on each side of the axis. Or you could think of it as the y-axis cuts the function perfectly in half, and it has the exact same image on each side. Then we have symmetric about the x-axis. So this first symmetry is symmetric about the y-axis. This second symmetry is symmetric about the x-axis. So here on this one we see the x-axis perfectly cuts our function in half, and above and below it has the exact same image. Sorry, I had to fix the focus. Just realized you guys were looking at a slightly blurry image. So we have symmetric about the y-axis, which means left and right are exactly the same. Then we have symmetric about the x-axis, which means top and bottom are exactly the same. And then lastly, our final example is symmetric about origin. All right, origin being 0.00. That means it's symmetric about both x and y. A really good example of this is a circle. However, there are functions like hyperbolas and parabolas that are also symmetric about origin. So the key thing here is if I cut it left and right, I have the same image on either side. If I cut it top and bottom, it has the same image on top and bottom. That's symmetric about origin. Now there's a key thing here to symmetry, and I'll go ahead and show you the work I did. So if we were to look at two functions here, let's look at these two functions. This function, we have x4 minus minus x squared, and then here we have x2 plus x1. Now, in this first function, we determined that it was symmetric about the y-axis because of a key feature of symmetric functions, which I have to show you over here. If a function is going to be symmetric about y, whether the x is positive or negative or positive, y will have the same value. For example, here we see at -2, y is 4. At +2, y is 4. So that's how I know it's symmetric about y. The value of y remains constant with the positive and the negative, and we can see that as it rises. It doesn't matter if the number is positive or negative, y will be the same because it's right in the middle. And then same thing with x. If it's going to be symmetric around x, whether y is positive or negative, x will still be the same. And we see that with these 2 points here. So these two functions that I tested, x to the 4 minus x squared and x squared plus x1, show us something very interesting once we start plugging in points on an x and y graph. If we have a function with even numbered exponents, the negatives for, like, say, -1 and -2, they will always cancel out and become positive because I have an even exponent, right? So with x2, the -2's became a +4. x4, the -2's became a +16, right? So with even number exponents, I get the exact same value every time because the negatives are getting treated like positives. Now, if I have an odd number of exponents, like right here, my -1 stayed negative and my -2 stayed negative. However, when I plug in +1 and +2, I get different answers. So, if you have an exponent that is odd, doesn't matter how big or small, it could be 1, 3, 5, 7, 9, 99. If you have an odd exponent, that means your equation is, or your function is not going to be symmetric about one of the axes. So that's symmetry, and you can spot it by looking at your functions by checking the exponent of the function, whether it's odd or even. Even numbers, symmetric. Odd numbers, no. Now let's talk about reflections. So, reflections are kind of like, if you think about a mirror image, and reflections can be done on the x-axis or on the y-axis. Here. So this reflection is up and down. Here, this reflection is left and right. So we have the y-axis. We have a function that starts at -4, and then we have the same function, but it starts at +4. So a reflection can either shift your function to the left and right to where it matches like the way you might close a book, and it would reflect like that, or it might reflect top and bottom, like, for example, someone looking into a pond. Now, what causes that to happen? Well, if we examine the equation of these two functions closely, what we see here is in order to make the reflection jump from left to right, they applied a negative to each x in the equation, right? So if you take each x value and you put a negative in front of it, that will make the function jump left and right, or it will reflect to the left and right. Now, if in this bottom one, let's look at what they did. It looks like here in the new equation, so we have the old equation right here. In the new equation, they took the entire equation and they put one negative outside of parentheses around the entire equation. Right? So instead of doing a negative at every x, like they did here on their new equation, here they put a negative outside of the entire function. And that's what makes it flip upside down. And then you can see the graph points that they use to prove that here by using their plug-in method. But the key thing here is if you want to reflect a function left and right, you apply a negative to every individual x value. If you want to reflect a function top and or up and down, then you apply one negative outside of the entire function. Last thing we're going to talk about, translations. So translations are shifts in functions. And these are some very, very good rules to remember. So a translation will shift a function up and down or left and right. Now, as opposed to a reflection just takes the point of the function and then immediately reflects it to the exact opposite portion of the graph. Whereas a translation, you can do fine movements. If I forgot, like for example here on my example, I've got here I have the graph of x squared. And let's say I want to move that graph of x squared exactly 4 spaces to the right. I can use a translation to do that. Now the question is, how do I get that graph to go 4 spaces to the right? The key is writing it out in equation form. So at y equals x squared, which is this one right here, I need to figure out what y equals x squared over here will be. So I can do that by testing this function. So over here, at y equaling 0, x equals 0. However, over here, when y equals 0, x equals 4. So, my equation, how can I change this to where I will get a 4 instead of a 0? Let's see here. What can I do? How can you change x squared? So, I mean, I want x to be 4. So, if x is going to be 4, then I'm going to have 4 squared. But y can't equal 4 squared. It has to equal 0. So how can I make x still be 4, but then the problem equals 0? Well, what if I had x minus 4, right? What if I put x minus 4, and then I squared that, right? So this way, when I plug this in, if I were to plug 4 into here, 4 minus 4 would be 0, 0 squared would be y. All right, so that's exactly how this works. This equation right here is x minus 4 squared. So if you want to track a translation, you want to look at the very origin of your function, where it moves from 0, 0. In this case, the origin moved 4 to the right. Now, typically we would think that as being positive 4, right? But we actually have to counteract that movement in order to keep y at 0, which is why we subtract 4 from the x. And we do it right next to the x. So if I want to move on the x-axis, I'm going to go directly to my x, and I'm going to add or subtract the number of spaces I want to move. Like, for example, if I wanted to do this same parabola, but all the way over here at negative 1, 2, 3, 4, 5, 6, 7, at negative 7, and I wanted to mark this same parabola, this would be the equation of y equals x plus 7 in parentheses squared, right? So shifting left and right works just like that. I take my x, right next to my x, inside parentheses, I put the shift, but I use the opposite number, all right? So that's a left and right translation. Now what about an up and down translation? What if I want to take this graph and I want to move it up, right? Let's say I want to move it up 4 spaces, right? So I want it to start here, and I want it to go like that. I don't want it to be touching the bottom level, right? what I'm going to do there is I'm then just going to add. So remember, I'm tracking my origin. And the origin of this function is now at 0, 4. So I need x to still equal 0, but I want my y to now be 4. And I need to adjust the y equals x squared equation to do that. Well, to do that, if x is 0, 0 squared will still be 0. But if I want y to be 4, I can just add 4 on the outside of it. So if I take this equation, y equals x squared plus 4, right? Or, well, maybe I'll write that down here so you guys can see it a little bit better. Y equals x squared plus 4. What that does is that gets me directly to the spot on origin. Whereas if x is 0, which it has to be on that spot, then y will still be 4, because 0 plus 4 will give me y of 4, and that's exactly what I'm going for. So to move up and down, you'll notice I didn't have to change the sign was the same. Now if I wanted to move down 4, say if I wanted it to start all the way down here, right, and I wanted that to be where my function goes, that would be y equals x squared minus 4. Now let's say I wanted to do a left shift, or let's say I wanted to do an up shift and a right shift. Let's say I want my function to begin at 4, 4. Well, then I'm going to do both of those. I'm going to put the function of y equals x minus 4 squared, because that brings me over to the right, and then I'm going to add 4 on the end, plus 4, to bring me up to here. And then I have the function starting at that point right there. Right? So that's the general form of translations. That's how you move left and right. This works with more than just parabolas. As you see here, this will also work with radicals, and it'll work with all kinds of equations. The general key here is that same form. If you want to move the x-axis, you make your adjustment right next to x. If you want to move the y-axis, you put the adjustment outside of the x value. If you have any questions, let me know on Moodle, and I will see you in class.